And you see here the mass density is 1006. Here also 1006. But now we have greater than 1018 because of now CO2 being dissolved into the water, making the brine heavier and more dense. Okay, so you get that. It's very interesting. Now we can also check the time series plot as usual. Okay, so now we go to time series and special history. Now let's see the 3A and then special history. Now let's see the CO2 supercritical first. Add to new plot. Okay, so now CO2 supercritical, the profile decreases, shows decreasing trend. Why? Because as we move across time, as we move forward across time, more and more CO2 now will be dissolved into the water. Okay, so that's why we'll have less supercritical CO2. Let's plot CO2 trap. Okay. Let's plot CO2 mineral. Of course, it will be 0. CO2 liquid, 0. CO2 gas, 0. CO2 ions, 0. CO2 dissolve. You have value there. Okay. So now let's delete curve. Sorry. Should be this. Okay. Lastly. Okay. Let's plot CO2 dissolve again. Now you have CO2 being dissolved. This explains why you have decreasing CO2 supercritical, because more and more CO2 will be trapped being dissolved into the brine. Okay, and of course we can compare CO2 supercritical. I want to compare CO2 supercritical first from 3 cases. Like this, from structural trapping, it is higher, and structural plus hysteresis trapping, it has the same value with CO2 trapped by structural trapping only. Okay, you have less CO2 supercritical because more and more CO2 being dissolved into the water, which makes now CO2 no longer in free state, supercritical free state. It is now another entity. It's no longer actually pure free CO2 because CO2 dissolved into the brine. Okay. Okay, and let's delete curve again. Delete curve. Delete curve. Let's compare 3A special history 3A. Now CO2 trap. It's like this. Compare it to structural only. Okay. And structural plus hysteresis. Okay.